Okay, so I don't know what happened with that other video, but so I have the square root of 7 on the screen, okay, and I'm going to press enter, and it's going to give me this wonderful irrational number. No repeating, it's just going to keep on going forever. So we're going to I'm going to do an approximation 2.65. That'll make our lives a little bit easier. So we have 2.65, okay, the positive version, is equal to the x plus 4, and we have negative 2.65 is equals x plus 4. We're going to subtract a 4 on both sides on here. So negative 2.65 subtract a 4. We're going to get 6.65 is my x value, and then this one 2.65 minus the 4. Oopsie, clear. Yeah, I'm subtracting 4. 2.65. I'm really tired, guys, so I apologize if I'm making weird mistakes. Minus 4. 1.35. Okay. So subtract a 4, subtract a 4. We have negative 1.35 is equal to x. Okay, so there's your approximations for your x-intercepts, and I would rather much have those than the things that they gave you in the hints. So the next thing is asked, which is really what this is up here anyways. So the next thing it asks you is the x-intercepts are so and so and so and so, which is what you have. So please don't forget to actually finish out the problem. Since you have negative 1.35 and negative 6.65, then that goes up here. So negative 1.35 and negative 6.65. So those are your x-intercepts. And we're going to graph them in just a second, after I actually go through the rest of this problem really quick. What are the approximates? Okay, we sketch a graph of the parabola. Okay, so here's the tricky part with this. Okay, it's kind of hard to sketch this if we don't know some specific things. Y-intercept, when it looks like this, is kind of hard to figure out what it is. So we're going to just kind of ballpark it for a second, just so I can get to kind of a point that I'm trying to get at. So we're going to have a parabola. Oopsie. I should really do this kind of like in the middle here. Okay, there we go. That's a little bit better. We have, okay, negative 1.35. So here's negative 1, here's negative 2, negative 1.35 is probably going to be negative 1.35. It's going to be somewhere here. And then the other one is negative 6. So 2, 3, 4, 5, negative 6, negative 7, so negative 6.65, so negative 6.65. So we know this is going up because the first, there's no negative out in front, so this is going to look something like, actually I should do this pencil. This might help you a little bit more. Okay, it's going to look like this, something like that. Okay, now the trick is, how far down does it go? How far up does it go? Why doesn't it go like this? How do I know that it's going to go down? What if it goes further down? I don't know. So that's what the next question is. Refer to the math list. Are the solutions to the equation irrational or irrational? Yes, they're irrational because they're not nice. And then explain. And then it says, we just did it. We explained it by showing our work. Square root of 7 is not a perfect square. So what are the coordinates of the vertex of the parabola? Is your answer exact or approximate? So this is the weird part, because it says negative 4, negative 7, and then exact. And so from what I remember, we didn't really cover, I mean, we kind of did, but we really didn't cover that much on the vertex. So this is kind of a crash course here. So your answer in part C has to deal with your vertex. Now, from what I remember telling you guys, you actually find the vertex from going halfway in between these two and then plugging that number into the equation. So we're going to do that right now. We're going to plug in halfway between negative 6.65 and negative 1.35. So the way I find the exact point in the middle, me personally, is I just kind of add them up and then divide by 2. So I go, okay, 6.65 plus 1.35. Okay, I don't take the negative. I just go straight with the numbers. I get 8, and then if I divide 8 by 2, I get 4. So that means, okay, I'm going to do that reasoning one more time. So between 6.65 and 1.35, okay, I literally plugged in those numbers just the way that they are without the negatives. You could talk about the absolute value as a distance and all that stuff, but right now I'm just shooting for getting it fast. And then I got 8. Okay, and then I divided by 2 because we want to go halfway in the middle between the x-intercepts, and then I got 4. So now I know in my head, somewhere in here, that around -4, okay, it just so happens that this is where the line of symmetry is for the parabola. So if I take the -4 and plug it back into my equation for my parabola, I should be able to find the x-intercept. Okay, so let's do that. We have y equals... parentheses -4 plus 4 squared minus 7. So this is going to equal, 0 squared, right? -4 plus 4 minus 7. And then I just get 0 squared is just 0. So 0 minus 7 is just -7. So my y-intercept is going to be at -4, and then I got to go down to -7. So let's see, 1, 2, 3, 4, 5, 6, 7. Oh! Awesome, I made it barely. So realistically, I didn't hit it all the way. I should have gone a little bit higher. Okay, so it's going to go down. Down here, and then come back up again. It's going to have a curve to it. Ignore the V shape because it's not right. And we're done. So now, let's see. Our vertex is at -4, -7. And then looking at -4, -7, I'm thinking to myself, wait a minute. Didn't I see this -4 and a -7 somewhere before? And then I'm like, oh yeah, there it is. My vertex happened to be -4, -7. Hint. Is there something maybe familiar about it that we can maybe use the equation to figure out the thing? But we're not there yet. We're not there yet. So plugging it in, okay, halfway between 6.65 and -1.35, it's going to be -4. You can add them up, divide by 2, plug the -4 into the equation, and then you get the y value for the vertex, and it's going to go up. Okay, so that was 65, and it was super long. Really long, actually. All right, so number 66, it says, Gabby is helping her friend Joaquin create a square tile design in his backyard. Joaquin has one large square tile that is no longer being manufactured. Randomly, he has a square tile. He also has 8 rectangular tiles that have the same side length as the large tile, and one small square tile that has the same width as the rectangular tiles. Gabby gets the algebra tiles to model the situation. How many square tiles does Joaquin need to buy to complete the square tile design? Okay, so I'm going to pause for a second here, and I'm going to go get my algebra tiles because it'll be so much easier to actually work with. Hold on a second. Okay, so we have an x squared piece. So we have an x squared piece. There's my x squared piece. I'm going to zoom out. Okay, we have how many? One little tiny one piece, and oh my goodness, 1, 2, 3, 4, 5, 6, 7, 8. 8 of these guys. 8. 2, 3, 4, 3, 4. Oopsie. 5, 6, 7, 8. Oh, I probably should have gotten these together before I actually made the video. Okay, so we've got to make a... Gabby gets her to model this situation. So he wants to make a square design. Exactly square. So by square, we literally mean not a rectangle. So this literally has to have the same width as the same length. So to save on time, okay, I would do... Okay, so let's say we go this way, And then we go, oh, okay, we go up the same amount. Okay, 1, 2, 3, 4. And then I look at this and I'm like, okay, so far I have the same. I have 4 and then an X, and I have an X and then 4, but I only have one of these guys, right? What am I going to do? Well, the question is, how many more do I need to fill? Because it says, how many small square tiles does Joaquin need to buy in order to complete the entire design? So he really needs to, he only has one, right? So he really needs to buy, what does he need to buy? He needs to buy, let's see. Well, to start with, we need a 4x4, right? So we only have one. A 4x4 here. This is technically like a 4x4. This is a 4x4 that we need to fill. We only have one to fill in. So we will need some more. Okay, so we need to add, oh my goodness, we need to add 15, right? 15 small squares to make this a perfect square. A perfect square. It would be so nice to make this square so perfect. So what they said was like, okay, well, to make this a perfect square, we have an X, right? We have 1, 1, 1, 1, and we have an X, and we have 1, 1, 1, 1. So a perfect square would be something like, well, perfect on the bottom, perfect on the side would mean I would have X plus 4 times X plus 4. Okay, X plus 4 times X plus 4. So perfect on the bottom would be an X plus 4, and then perfect on the side would be an X plus 4. Okay, but if I do that, I'm missing some pieces, because realistically, X plus 4 times X plus 4 is X squared plus the 8X plus the 16. Okay, well, I don't have that many pieces. I want to get this, but all I have right now, this is what I want. Okay, what I have right now is I have an X squared piece. I have 8 of the pieces, so that's good, but I only have 1, right? That's what it's up here, plus question mark. Well, I know that I need 15. I shouldn't use that. I know I need 15 more of the small pieces, 15 of them, in order to make this perfect on the side, perfect on the bottom. So I really should add 15 to it, right? So that's how you would do it realistically. You want to be perfect. You want it to be an X plus 2 or X plus 4 and X plus 4. But that would require you to have 16 of the small ones. You have this many, so you really need to add 15. And if you do that, you should get the X squared plus the 8X plus the 16. Okay, so your answer is 15 tiles. All right, so those are the two more interesting ones. So if you have any questions, you can see me in class.